We have one more speaker lined up, one more conventional, well, that sounds bad. I don't mean it like that. One regular speaker lined up. He is coming to the stage right now. His name is Forbes Lindesay. We have covered a pretty wide range of topics today. And I think we have touched upon pretty much all the trending and relevant stuff in React World 2017, except maybe for one pretty major field, which is kind of new maybe in the JavaScript world, but gaining in importance. And I'm talking about type checking, a field in which Facebook has been very active with their Flow library. And that is why we have invited Forbes from Facebook in London to come here and tell us all about it. Forbes, are you ready?
Very nearly.
Great. Give it up for Forbes Lindesay.
Hi, I'm Forbes. I don't work for the Flow team at Facebook, so what you're going to get now are very much my personal opinions that come from spending a lot of time working on a very large code base that uses Flow, but they're not necessarily deep insights into what the Flow team at Facebook is thinking. So I'm going to cover three kind of key sections today in this talk. I'm going to start with why you should use Flow, and in fact, why you should use any kind of static analysis tool. I'm going to talk a little bit about how you set up Flow, the basics of getting started, and then I'm going to give you some tips and tricks that should both help people who are already using Flow in production, people who already have some experience, and will help you avoid some pitfalls if you're just starting out. So let's start with why Flow. You've seen this pyramid before. In fact, it was in an earlier talk. This is this old idea that we have lots of unit tests, a small number of integration tests, and then an even smaller number of end-to-end tests. And this model feels pretty outdated to me. I like to draw this pyramid instead. So we start with static analysis at the bottom. That's ESLint, Flow, TypeScript, all of those kind of things. We then have JavaScript tests, and I'm not going to distinguish between whether those are integration tests or unit tests. All that really matters is how much value are you getting out of that test, and how long did it take you to write, and how long does the test take to run. These kind of putting things in categories isn't that helpful. Then we have end-to-end tests, which is WebDriver, and I also have my own open source project called Cabby that is a WebDriver client written in JavaScript, so feel free to check that out. But today, I'm talking about static analysis. So why static analysis? One of the key things about static analysis is that you can use it to cover 100% of your code. Whereas with tests, it's really difficult to get every single branch, every single combination completely covered. With static analysis, every single branch, every single line of code, every expression is properly covered. Another reason is it gives you a form of built-in documentation. So you know that, that if it says it's a string, it's actually a string. You annotate your code with the types as you go through. And those types are verified, so you know that there's no incorrect assumptions. So whereas with documentation that might be written in comments, something like JSDoc, that kind of thing, you never really know whether those are up to date or whether the programmer who wrote those initial comments checked that those were right. If those are Flow types, then you know they're correct. And the other thing it does is help make refactoring code much safer and much easier. So how does ESLint and Flow differ? ESLint and other linting tools help you catch really basic mistakes. So they'll catch things like a variable that you haven't declared, and that's because that requires very little actual analysis of the code. All you need to do is look for references to variables and then see if there's a declaration of that same variable. If there isn't, you found an undeclared variable. They can detect key patterns that you don't want to use, things like the fact that you might not want to leave a debugger statement in your code when you ship to production. And they can catch things like white space errors and formatting if you have specific rules around formatting. And for this, Prettier is actually great, so I'd recommend trying that out if you're currently using ESLint for that particular use case. Flow catches much more subtle and complicated bugs. So in this example, I've got some function that takes a string and logs it, but I've annotated it using flow. So that colon string after the v argument of the log string function says this value is a string. And flow is therefore going to point out that the value I'm passing to log string actually isn't a string, because the curly braces there say it's an object literal. So I'm passing an object here into a function that I expected to receive a string, and flow will be able to match up those two and say, hey, these don't match. And that's something that, yes, in any specific example like this, you could write a complicated ESLint rule to figure that out. But you can't write that ESLint rule in the generic case for every single possibility. I mentioned that it's great for refactoring. So a possible example of this might be if you had a function, say, setLocation, that takes a latitude and a longitude, two numbers, as two separate parameters, and you wanted to change that to say, actually, we'll take a single object that has a latitude property and a longitude property. That refactor can be really hard to do safely in a very large code base, but Flow can identify that the type of the object coordinates does not match the two separate number arguments. So it will identify any of the call sites of this function that haven't been converted to your new post-refactor methodology. If you've used type systems in the past, there's a good chance you've used type systems from a language like Java or C#. And these are kind of cobbled together, complicated machines, these type systems. And if you look at type systems in languages like Java and C#, what you'll find is that they don't produce soundness. And what that means is that you can have a null value, and you can pass a null value to any function in Java and C#, and they'll assume that that's fine, but they'll also assume inside the function that the value isn't null and that you can access properties of it. And that combination leads to a lot of bugs. It leads to runtime exceptions. With Flow, it really focuses on soundness. So if you have your entire code base typed with Flow, you really will get almost no runtime exceptions. It's really hard to get a runtime exception with a properly Flow-typed code base. Now, it would be remiss of me not to mention TypeScript. It's very much the elephant in the room. I believe it's a great alternative. If my hope is that you use a type system, not necessarily that you use Flow. I don't actually have any personal experience of TypeScript, so I can't really talk to its pros and cons. But my understanding is that it's more of a full compiler, whereas Flow tends more towards adding annotations, but not actually adding other language features. And it leaves it to tools like Babel to actually extend the language. Flow, as far as I'm aware, seems much more popular in the React community, and it's certainly what's used at Facebook. Another reason why Flow might differ from other more traditional type systems you've seen in other languages is that Flow offers escape hatches. One of the great powers of the JavaScript language has been its flexibility for experiments. It's really easy to try something out in JavaScript, and you don't need to worry about whether your code is 100% correct for every possible case from the start. You can kind of cobble something together, see if it works, and once you've got it kind of working, then you could worry about checking things with types. And Flow supports that workflow by offering two key escape hatches. The first is any function and object. These are free types that don't really verify much of anything. So any will let you, is a type, you can use it instead of string or number or object, but any will let you pass in literally any value. It won't check anything about that value, but it'll also let you assume anything about that value. So it'll let you assume that that value has a certain property, it'll let you assume that value is a string, but it'll also let you pass in an object that doesn't have that property or pass in a number instead of a string. So this does lead to runtime exceptions, but it's a trade-off, and it lets you say, actually, I don't want Flow's help for this particular part of the code. Function and object are very similar in that function verifies that the value is a function, but it doesn't verify that it has any given number of arguments or that it returns any particular type of value. An object is similar in that it verifies it's an object, but it says nothing about what properties that object has. The other escape hatch is flow fix me. Flow fix me lets you say in a comment, ignore the next line, and flow will ignore any error on the next line. Hugely useful if you know that some code is right and you can explain why it's right to your coworkers, but for some reason you can't explain it to the flow type checker. One of the nice things about this is that flow actually enforces that there is an error on the next line if you've put a flow fix me comment there. So if you see a flow fix me comment in the code base, you know that there's a type error on the next line, which is a really nice kind of signaling thing. You never get these redundantly left in the code base, even though the code's actually type checking fine. So hopefully I've justified why I think you should use flow. I'm now going to talk about how you get started, how you set up flow, and how you might publish a module to NPM that uses flow. So to start off with, you npm install flow bin. Wait, that's not right. You yarn add flow bin. And having done that, it's as simple as running flow. You can add it, if you add flow bin to your package.json as a dev dependency, you can put flow in the script, so you don't have to go around every single colleague and go, you need to run this command to install this command line globally. And once you have flow there, you can run flow, and flow will check any of the files that are flow typed. It will do that straight away, but you'll usually find it doesn't give you any errors, because you have to start by adding this comment to the start of any file you want flow to check. So flow will check any file that has this @flow anywhere in the file. That opt-in approach is really useful for converting legacy systems to use flow, because it means you can just add flow typing one file at a time, work your way through the whole code base, and eventually get to 100% coverage. Okay, so you've got flow running on your types, running on your files, but this is a React conference, so we want to add flow types to a React component. So how do we do that? Well, we start by declaring a type called props. You can call it whatever you like, but I prefer props for this particular one. The syntax looks just like an object literal syntax. So this would be defining the props for a component that takes a value of type string and an onChange function that itself takes an argument that's a value of type string. And that function I've said returns mixed here. Now mixed is a kind of special value. It's a bit like any, but unlike any, it's not a true escape hatch. It's actually safe. It's sound. So what mixed does rather is let you assign any value to that variable, or in this case, return any value from that function, but instead mixed verifies that you can't ever interact with that value. So I could have said void here. I could have said the onChange function has to return undefined. But by saying mixed, I'm instead going, I promise not to depend on the value this function returns. So flow will verify that my component doesn't depend on that function returning undefined, which then means that I can pass in a function that doesn't return undefined, which in particular is useful if you want to pass in an arrow function, because that might end up returning a value that you don't care about. When we've done that, we might also want to declare a type for the state, if there is any. So this declares that the state has a count property of type number. And once we've declared our two objects, we can simply assign them to our component and say that props is of type props and state is of type state. And we can give it a default value as well in line there if we have the appropriate Babel transform enabled. If you're using the newer functional style components, then it's a very similar approach. Declare a type props to declare the types of each of your props, and then use that as the type for the props argument to your functional component. Flow will also give you a flow config file. This is useful if you want to ignore any node modules. So in particular, if someone has published a module on NPM that has flow types, but those flow types are incorrect, then it can be useful just to ignore it and say, OK, just forget about the flow types in this particular module. So flow there is letting you pass in a regular expression to say which which modules you want to be ignored and which ones you don't. By default, Flow will run across all of the node modules, all of the third-party code, as well as your first-party code, as well as the code you've written. Flow-typed is a really useful module. So this solves the problem of third-party code that's been written by developers who didn't add flow types. So flow-typed is just a simple command line utility. You can install it with npm, and then you run it by typing flow-typed install. And when you do that, flow-typed will look in a central repository to see if anyone has published flow definition files for any of the npm packages that you depend on. And if it has, it will fetch those and add those in for you. And if not, it will create little stubs for you to fill in for those third-party dependencies. And then it will tell you how to contribute those back to the central repository of flow types. So that's super useful for that. But let's say you're publishing a module to npm, and you're using Flow internally in writing the module, and you want to be a good citizen, so you want to make sure that those flow types are available to everyone that consumes your package. Well, you actually need to start by using Babel to remove the flow types, because if you don't remove the flow types, then anyone who's not compiling their code using Flow will be unable to use your module. You should only publish code to npm that can be run without transpiling it. So you need to do that transpilation step. But you want to expose the flow types to your users. So you see this useful option to transform the flow types to a comment. But what you find is that that doesn't work. You can't actually use that reliably, because you're going to want to transform away other ES6 features. You're going to want to get rid of the class syntax, and you're going to want to get rid of arrow functions and things like that. You don't want those often in your published code, but if you transpile those away, then your code becomes unintelligible and not comprehensible for Flow. Flow can't understand the output of Babel. So you need to publish your original source for Flow somehow. Unfortunately, there's a way you can do this. If you publish a file with the same name as another file, except with a .flow appended to the end of it, then Flow will read that file instead of the original file, but all the other tools will use the original file. So all you need to do to publish your flow types is copy them into the same directory as your build output, copy the original source into the same directory as your build output, while appending .flow. Fortunately, you don't have to do this manually. Someone has helpfully published an npm module called flow copy source that does this for you. Next, runtime type checking. So not all of your package users will have Flow, so you might want to consider something called Flow runtime. And Flow runtime lets you optionally compile Flow into runtime type checks. So this is great for users who don't have Flow in their own code. This lets you provide runtime exceptions, but provide them really early. So before they've got deep into the guts of your complicated module, right at the boundary, you can go, this argument you're passing me is not the type I expected you to pass me. The only problem is it's too slow to use in production. So what this actually means is you have to build two versions if you're doing this, and swap between them using the node env environment variable that lets you tell whether the person is using your module in production or development. And if they're using it in production mode, then you use the version that has all of the flow just compiled completely away. And if they're using it in development, you can give them the version that has Flow compiled into runtime type checks. So you've decided you want to use Flow. Hopefully I've convinced at least some of you. You've got it set up now, and it's all working fine. What problems are you going to run into? What tips and tricks can I give you to help? Well, we mentioned any object and function earlier, and now I'm afraid I'm going to have to tell you, don't use them. They're really unsafe. So as soon as you have any object and function in your code, unsafe values will begin to permeate through your application, and you'll start being unable to rely on the Flow type checks. So avoid them at all costs. If you can, don't use them. But if you have some huge module and it's legacy code and it didn't have any type checks, and you can add good, useful type checks to 90% of the code. If you can ignore one little bit by just labeling it as any, then they're useful in that context. Mixed is fine, as we discussed. Mixed is safe because it doesn't let you access the value inside that mixed. So this is a great thing to use as the return value for callbacks. Return values for callbacks should always use the type mixed. Exact object types are a new and very useful feature that catch a really common kind of mistake. So in this example, I've declared a type that is an object that has a property value that's optional. So that question mark after the word value there means that that property is optional. We don't have to provide it, but if we provide a value, it has to be of type string. Then I've tried declaring an object to match this type, but I've made a mistake. I forgot that I'd used the full word value. I thought I'd shortened it to val. So I've said the val is a string. Now, Flow won't complain at this, because as far as Flow is concerned, we just haven't provided a value for the optional value called value, and it's not a problem that we've provided some extra things that we don't need. So although as humans we can see that this person has probably made a mistake, the Flow compiler can't tell. And the way we can help Flow to spot this kind of error is to use exact object types. So in this example, I've added those vertical bars either side of the object in the Flow type definition. And what that says is this is an exact type. So I'm saying here are listed all of the properties that this object is allowed to have. So now the error I will get from Flow will say, there's no property val in this type definition, but you've provided a property val. So I'll get a helpful error message telling me I've made a mistake, telling me what I need to fix. Next, I'm going to talk about read-only arrays. So we'll start by looking at an example with a writable array. So if we imagine a function add nullable string that takes an array of nullable strings and a nullable string and puts that value on the end of the array. That seems fine. If we imagine we pass an array of not nullable strings to it and the value null, we can see that's going to create problems, because what we've done now is we've said we're going to declare this value that's an array of strings, and then we give it to this add nullable string method, and that adds null into it. So now we've got a value that we thought was an array of strings, but now it's actually an array containing the value null. So that's clearly a problem. Flow is going to warn us about this, and Flow is going to warn us about this at the point where we try and pass an array of strings to a function that expected an array of nullable strings. Hopefully everyone's with me so far. If we have a read-only array, so now I'm going to give an example where you might have thought this would work fine, but hopefully now you'll be able to see why it doesn't. So we have a function now, log nullable strings, that takes an array of nullable strings and logs each value. We attempt to pass in an array of strings, which should work fine. None of this code is going to have any runtime exceptions, but Flow is going to give us an error, because as far as Flow is concerned, it doesn't know that log nullable string isn't going to modify that array. So it's going to give us an error saying you can't pass this array of strings into this function that expects an array of nullable strings. So the solution to that is to tell Flow that the array is read-only. So we just use a type of read-only array instead of array, and Flow is completely happy now. Now Flow says it's fine to pass an array of strings into a function expecting a read-only array of nullable strings, because all of those values in the array are going to be nullable strings. They just all happen to not be null. If we tried to change the array into a read-only array in our earlier example in add nullable string, then we'd run up against the problem that we can't push into a read-only array. So we change where the error is, but we still get an error. So Flow understands that this code isn't actually valid. This code is wrong. The same thing happens with the read-only property, but I'm running a bit low on time, so I'm going to rush through this example slightly. So if we have an object that has a value property that's mutable, if you update that value, then you could be writing null to it. So Flow won't let us pass in an object with a value of type string into a function that expects an object with a value property that's a nullable string. You can see the same thing if we were only reading that value, then that's not a problem. If we're just logging the value, then why should this be a problem? But Flow's still going to complain because Flow doesn't know we're not updating that value. The way we fix that is we mark the property as read-only. Now, Flow has a syntax for this that's a plus. So that plus means read-only. It has a fancy name. It's called covariant. But covariant really is just a fancy word for read-only. The other words you might see in this context are contravariant, which means write-only, which is somewhat less common, and invariant, which means readable and writable. But all of these are just fancy words. I just tend to stick to read-only, write-only, etc. And similarly with the array, if we said that that property was read-only, then we wouldn't be able to assign a value to it. So based on this, 2 recommendations. Use read-only array by default, and use read-only properties by default. It will make the errors you get from Flow match what you would expect to see. So it'll make them quicker to fix, because if you were expecting the array to be writable, you can just replace it with a mutable array, problem solved. And if you were expecting it to be read-only, then you've just found a bug in your code. So that's also helpful. Now, I want to use the last couple of minutes to run through a real-ish example. I've modified this slightly, but this is very similar to a problem I had to face in real life. So if we imagine a reverse string function that takes a nullable string, if the string was null, it returns that string. If the string was null, it returns null. Otherwise, it reverses the string. Now, if you were writing this code from scratch, you just wouldn't. You just wouldn't accept the null value. You'd let people who are calling this function deal with the null value. But if you're dealing with this from legacy code, you want to change the behavior as little as possible while adding flow types, you might end up getting a bit stuck. So the naive solution is, OK, it accepts a nullable string. It returns a nullable string. But then you find code like this in your code base, where it's passing in a string that it knows is not null, and it's expecting a string that's not null as the result. Now, you know from reading the code that this is fine. This isn't a problem. But the flow types you've just said say that this function returns a nullable string, and you're assuming it returns a string, so you're stuck. OK, so you say, fair enough, this should return a not null string. So you make it take a string as an argument, return a not null string as its result, and you remove that weird thing where you say if null, return null. Now you've got the same problem in reverse, in that somewhere in your code you're passing null into a reverse string, and you're expecting a nullable string as a result, and suddenly you're getting flow errors again. So how can you make this code flow typed without changing the behavior? The answer is generics. So you can say, what this really does is it says actually the type that this function returns is the same as the type of the value it takes in. So that bit in angle brackets at the start there, where we're saying t of type nullable string, says we take some type that is a subclass of nullable string. So that could become string, or it could become nullable string. We don't know which yet. But that type is the same one as the type of the argument, and the same as the type of the result. So now, if we pass a string in, Flow will know that we're going to get a string out. And if we pass a nullable string in, Flow knows we'll get a nullable string out. So both the 2 valid examples are fine with that. And then Flow also is capable of spotting that if we pass null in and we try and expect a string out, then that's going to be a problem. There's a slight mistake in this code, which is that Flow doesn't know that the null that we're returning is actually of type t. So we need to go a little bit further with this and say, actually, we're going to return string if it's null rather than returning null if it's null, which doesn't change the behavior of the code, but it just kind of tricks Flow into working. So hopefully, you now have seen the value of Flow. You can see that it helps prevent mistakes. It helps make your colleagues do the right thing, and it helps make future you less stupid. Hopefully, you know how to get started and get things set up. And hopefully, I've given you a few tips and tricks to help you through some of the common pitfalls and some of the more challenging parts of adding Flow to a code base. If I can leave you with one thing, it's this pyramid. This is the pyramid you should be thinking about when you're looking at improving the quality and reliability of your applications. Add end-to-end tests, but not very many of them. Add lots of tests in JavaScript. Don't worry about whether they're integration tests or unit tests. Just do whatever feels right at the time. And use tools like static analysis, because they really do help you write reliable software. Thank you.